Okay, so a couple of things that are reminders from the lab from yesterday. Okay, those reminders are, okay, that remember in the analysis, okay, what I'm looking for in question number 1 in the analysis, okay, is for the reactions in both word and formula form. Okay, obviously balance. Okay, and then I think I forgot with you guys to talk about question number 2 in the analysis. Okay, I know I talked about it with period 2, but when I was telling them about it, I think I forgot to talk about this with period 1. Okay, so question number 2 in the analysis on your lab from yesterday is asking you to identify the precipitates that form. You had 2 reactions that produced precipitates. Okay, so once you have written out, okay, the reactions in both word and formula form, so let's say we had a reaction that looked like this. Let's say we had sodium chloride plus, I think this will work, tin 2 nitrate or something like that, or tin 4 nitrate. Okay, and that made, you know, we predicted all the products, so we would have sodium nitrate, and we would have tin 4 chloride. Okay, now I don't remember if this is soluble or not, but this one for sure is. So what you would do is go, okay, this was one of the reactions that made a precipitate. Okay, then I've got to check which products are soluble. Okay, and if you would, whichever one isn't soluble according to your solubility chart, you just write in. Okay, the precipitate in reaction 1 was tin 4 chloride. Okay, and the precipitate in reaction 7 was this stuff. Okay, does that make sense? That's all I'm looking for. You don't have to do anything else. You just have to write the precipitate in reaction 1 was this. The precipitate in reaction whatever was this. Does that make sense? That's all you have to do for question number 2. Okay. All right. Okay. We're going to continue on here, guys, with just kind of practicing our prediction skills, balancing skills. Okay. My hope is that we are going to be doing our assignment on reactions on Thursday. Okay. It's 30 reactions. Okay. And you will have the whole class to work on it. Lots of times people finish the whole thing in class. Okay. And that'll be your final assessment on that. You'll have a quiz on Friday on predicting reactions, and then we will start the mole equation on Monday. Okay? And your unit exam will be October the 10th. Okay? We will probably be done before that, and we'll start biology. Okay? But that's the day I've set aside for the exam. Okay? If we start biology before that, that's no problem. Make sure you're planning ahead for that day. All right. Okay. All right. Let's. So we've already talked about the balancing. Okay. Law of conservation of mass. This is why we balance reactions. Okay. We already know how to do that, but the reason we do it is because matter cannot be created nor destroyed. That's the law of conservation of mass, or the law of conservation of matter, whichever. Okay, we must make sure that our reactants and our products have the same mass, and that means I have the same number of lead atoms on the reactant side as I have on the product side, and whatever else is in the equation works out. Okay, otherwise, obviously, I've created or destroyed some material. Okay. Now, with our balancing rules, okay, this is just kind of a quick, in fact, we'll just do this kind of a quick review here, okay? Our first rule for balancing applies to all reaction types except for combustion, which has its own rules, okay? And the number 1 rule is start with
the biggest number.
Right, with the biggest number. If that doesn't work, then you pick something else and you do that. Okay, but start with the biggest number. That's going to work the vast majority of the time. Okay, and that goes for all reactions except combustion. Okay, and then obviously for combustion, okay, our rules are, okay, rule number 1, balance alphabetically. Okay, and rule of 2. So even number of carbons, okay, start reaction with a 2. Okay, those are our rules for that. Okay, what are our steps for predicting? If I want to predict the products of a reaction, what's the first thing I need to do?
Decide what kind of reaction it's going to be.
Yes, if I'm given the products in, or sorry, the reactants in formula form, my first job is to figure out what kind of reaction it is. Today, I'm going to give you some that are in word form. So your first step is actually to write out the reactants in formula form, and then decide what type of reaction is going to occur. Okay? Once you've decided what kind of reaction occurs, then what do you do?
Decide what kind it is.
Yeah, that's what I mean. We decide what kind it is, and then once we've decided what kind it is, we
Write the results.
write the results. So we go, okay, I know in a synthesis reaction, these two elements are going to combine to form a compound. Or in a double replacement reaction, I'm going to swap the metals. Okay, and I use the pattern to determine who goes with who in the products. Okay, what do I have to check for in my products?
Special elements.
Right, special elements you got to check for. Actually, in both, right? If I give you the reactants in word form, you got to check for specials and what else? If I have an ionic compound?
Roman. Oh,
Nope. Drop
no.
and swap. Okay, make sure that I've dropped and swapped my ionic compounds. Okay, and then once I've done all of that, the last step is to balance the reaction. Okay, just remember those steps. It's always going to be the same steps. Okay. Come on. All right, so I got 4 there that I would like you guys to try. Okay? Products and balance. Just as a quick review. Then I'm going to give you some that are in words. Okay, that start out in words. Okay, what kind of reaction is the first one? Synthesis. Okay, so when those two go together, okay, synthesis reaction says they're going to go together, okay, makes what kind of compound?
Ionic.
Ionic compounds. Any of you dropped and swapped?
Yes.
Yes. Is it already?
Yes.
Yes. Okay, because they're both 2s, right? There's a -2 here, okay, and a +2 here, so they already come out to 0. Okay, now I need to balance the reaction. Biggest number is 2, so there's 2 oxygens in the reactants, but only 1 here in the products. So what do I do?
2.
Okay, that gives me 2 calcium, so
2.
right. Okay, and then for number 2, what kind of reaction are we looking at?
Decomposition.
Decomposition. Okay, in a decomposition reaction, this is going to split up. So we're going to have Mg plus S. Anything I need to watch for?
Sulfur is a special.
Right, sulfur is the most special of the special elements. Okay, it's an 8. Is magnesium special?
No.
No. Okay, so I've got 8 sulfur on that side. What needs to go here?
8.
Okay, then what needs to go here?
8.
Okay, and that would be like a 1. Okay. Oh, sorry.
My bad.
Okay. What kind of reaction is number 3?
Combustion.
Okay. What are always the products of a combustion reaction?
CO2 and H2O.
Okay. Okay. Does this one need the rule of 2? Okay. So what do I do now? Do it alphabetically. What goes here?
3.
Okay. And I have 8 hydrogens. So what goes here? I have 4 oxygens there, and how many here?
6.
Okay, 6 plus 4 is? Okay, what goes here?
5.
Okay, how many times have we done the reaction with propane? That's got to be like the 5th or 6th time we've done that particular reaction with propane. All right, last one.
Double replacement.
Double replacement. Okay, so in a double replacement reaction, I just
swap the metals.
Swap the metals to make my two new ionic compounds. So sodium will go with chlorine, and hydrogen will go with hydroxide. Both ionic compounds? Okay, +1, -1, that one okay? +1, -1, that one okay?
Yeah.
Okay, am I done? Yeah, reaction's already balanced. Okay, that's a neutralization reaction, double replacement reactions that involve an acid and a base. Okay, they neutralize each other, and what they produce are water and a salt of some kind. Okay? Guess I started my calculator.
So that, like, if you did mix those two, you would get like table salt and water?
I would get a solution of salty
Yeah.
water. Yes.
Yeah.
Yeah, exactly.
That's-
Now, I would have to make sure I had exactly the same number of everything so that it completely neutralized, okay, at the end. But yeah, that's what I would have, would be salt and water. Okay, literally table salt and water. Okay, questions on those? Okay, does it get more challenging if I give you the reactants in word form rather than in formula form?
Probably.
Yeah, it's not that it's harder, there's just more things you have to think about. Right? There's more opportunities to make a silly mistake, like, oh, I forgot that oxygen was supposed to be a 2 when it's by itself. Okay, things like that. So we want to practice some of those where we have that demand placed on us, okay, for having to be thorough. Where are the ones in words? Come on, words. There we are. Okay. All right, so this sheet is in your digital work or in your workbook. So if you have the workbook printed, okay, this one is in there. The first 5, the first ones are just balancing. The first 7 are balancing, okay, and the first 5 are pretty straightforward. 6 and 7 I threw in there in case you started to get a little cocky and needed to get humbled a little bit. Okay, those ones will be a little trickier to balance. And then after that, we've got prediction reactions in words. Okay, so what I'd like you guys to do is do 1 through 7 there first, do the balancing ones, then we'll have a look at those. If you get done the balancing ones, you can start on, let's say, 1 to 4. Okay, don't go further than 4, okay, on there. All right, if you don't have the workbook, here they are, right here on the board. For this week, for your quiz on Friday, the best practice quizzes are 10, 11, 12, and 13. Okay, they're all on just reactions and prediction and balancing and stuff. So those are the ones you can try if you want. Okay, number 3, magnesium solid and nitrogen gas react with each other. Okay, so what magnesium solid, would it look like that?
Mm-hmm.
Okay, nitrogen gas, what does that look like?
N2.
Right, special element. Okay, now that they're in words, that's one of the things that can easily be missed. What kind of reaction is that? Synthesis reaction. All right, so they're going to go together to make an ionic compound. That's a -3, that's a +2, so we're looking at Mg3 and 2 for our formula there. Okay, now I've dropped and swapped my ionic compound. So I think for balancing, I'm just going to need a 3, 1, 1 for that. Okay. Questions there? All right, and for number 4, magnesium nitride. Hey, look at that. We just figured that one out, so we don't even have to think. Mg3N2, okay, is mixed with water. Now, could I write this as H2O or HOH?
It's swap the 3 and the 2.
Oh, whoops. Yes, sorry. Got ahead of myself. I was so excited that I got to redo something I did wrong. Okay, could I write this as H2O or HOH?
Yes.
Yes, and either one would be correct. Okay, in replacement reactions, I would write it as HOH. But let's go with Mg is going to be with O, and H is going to be with N. Okay, -2 + 2, that compound's fine. H3N would be that one. Okay, and the other option could be you have MgOH2, and you would need a 2 in front of that, okay, for the OH. Okay. All right. I'll give you guys about a 5-minute break here. Oh, sorry, I didn't balance it. 3, 2, Okay, all right, I'm gonna give you guys about a 5-minute break here, and then I'm gonna put a few more up there for you to practice with, okay? And then we'll keep going. Okay, so for number 5 here, we got iron 2 sulfide. So ionic compound, Fe with S, sulfur's a -2, iron in this case is a +2, so that compound is dropped and swapped correctly, and it is reacting with oxygen gas. Okay, when you have a special element, okay, they're all nonmetals, including hydrogen. If it's in its H2 form, it is a nonmetal. Okay, it is a metal if it is listed first in an ionic compound. Okay, so we got Fe and it's reacting, sorry, with this one here, it's going to be a single replacement reaction. Who does oxygen replace? The sulfur. All right, so Fe and O are going to wind up together. That's a -2, that's a +2. That compound is fine the way it's written. Sulfur ends up alone. What do I have to remember about sulfur?
It's very special.
It's very special. Okay, so it's S8. Now we got to balance the whole reaction. Biggest number first. Okay, an 8 there balances the sulfurs, an 8 there balances the irons, and a 4 here balances the oxygens. Single replacement reactions are the ones you have to watch the most. Okay, because a single replacement reaction is always going to produce an ionic compound that has to be dropped and swapped. And it is likely it could produce a special element that has to be checked. Okay, in a decomposition reaction, you know you're always going to get a special element. Okay, in there, right? You just know to check for it. But in a single replacement reaction, you've got swapping and dropping you have to do, and special elements, okay, that you have to watch for. Okay, molybdenum sulfide, MOS. Molybdenum's a 2, right?
6.
It's a 6. Okay, see there. That's why I gotta ask. +6, -2, so MOS 3. Okay, for molybdenum sulfide, it's reacting with oxygen gas, which is O2. On a test or a quiz, I won't give that to you, by the way. You have to remember that oxygen is a special element. Okay, what kind of reaction are we looking at?
Single.
It's another single replacement reaction. Okay, so who does oxygen swap out? Sulfur, just like it did in the previous one. Okay, just now, oxygen ends up with molybdenum, Mu, okay, and sulfur ends up by itself. Sulfur's still special as an 8. This is a +6, that's a -2. 2, if I drop and swap, I get 2 and 6, which can be reduced to 1 and 3. So we got Mu 3, okay, and then we got to balance that. Gonna be some big numbers here. Right, I got 8 sulfur in the products and 3 in the reactants. Lowest common multiple? 24, yeah. So I'm going to put an 8 here and a 3 here in order to do that. 8 molybdenums there, 8 molybdenums there. That gives me 24 oxygens. What do I need to put here?
12.
Right. Okay, so some big, big numbers there. All right, how many people have done 7? All right, let's look at 7. So we got molybdenum oxide again, MOO3. We can carry that over from the previous one. And it reacts with hydrogen gas. Now I just finished saying that if you have hydrogen gas, H2, it's behaving as a non-metal because it is a molecular element in that form. Okay, so when that reaction happens, the hydrogen will swap out the oxygen. Okay, so mole. Okay, and O2. I think that's the way I have it on the key. Okay, if I don't, then the key is wrong. All right, so now that I've done that, what do I still need to do that I haven't done?
Drop and swap.
I need to drop and swap this. +6, -1, so looking like that. Probably want to do the oxygens first, even though H is a 6. I think I still want to do the oxygens first. 3 there, okay, and a 3, or sorry, a 2 here. Then I'm going to need to put a 2 there, and what goes here?
6.
Yeah, and then I think that works. Okay, not sure if I have it that way on the key, but that's the way it should be. Okay. Emma?
For the molybdenum, whatever it's called.
Yep.
How did you drop and swap that?
Oh, okay, so for the molybdenum, okay, what I did is I went MO, and it's a +6, okay, and it was with oxygen, which is a -2. So when I dropped and swapped, I got 2 and 6, but what do I have to do if I can?
Reduce.
I have to reduce. 2 and 6 can reduce down to 1 and 3. Good question. Okay. So ionic compounds, remember that we always reduce those. Okay. Molecular compounds, never, right? The prefixes tell us this is how many there are, and that's how many there are. Okay. All right, I'm gonna give you guys a few more minutes there on 8. I think I only had up to 11 on there, but we'll go 8 through 12 there. Okay, see how we do. What we got left of time. Okay, let's say, since we've only got 10 minutes left, let's see if we can get 8, 9, and 10 done, and I'll go over them before the bell goes. Okay, so for number 8, lithium is added to water, so Li plus, and again, we can write this HOH or H2O. I'm gonna write it HOH this time. Okay, single replacement reaction, lithium's gotta swap out with the hydrogen, so hydrogen will end up by itself, but it's special. Okay, lithium will end up with hydroxide, or you could have Li2O there for that one as well, and then we would have to come back and do this to make the reaction work. Okay. For number 9, barium is added to water. We had a lot of these ones added to water. Okay, HOH. Okay, so that's going to give me, again, hydrogen gas, barium hydroxide. Okay, dropped and swapped like that. Need a 2 there to make it all work. And then for number 10, copper 1 sulfide, Cu2S. Okay, reacting with oxygen gas. Okay, we got a single replacement reaction there where it's going to make copper 1 oxide, and that'll be Cu2O and sulfur dioxide. So a slightly different reaction there, not one we would have predicted. Okay, so to balance that thing out right now, we have 3 oxygens on that side and only 2 over here. So I'm going to double the odd thing. That's that odd even problem. Okay, by doing that, I now give myself 4 coppers on both sides. That gives me 2 sulfurs. I need to put a 2 there. Now I have 2 times 2 is 4, plus 2 more is 6. 3 times 2 is 6. It's a tricky balance, that one. Okay, you gotta think outside the box a little bit on that one. All right, so tomorrow I'm gonna come up with a few trickier ones, okay, for us to practice with. Thursday we'll do the assignment on reactions. Friday quiz on reactions. Monday, no equations. Okay?
No school.
We talked about this. Oh, sorry, Tuesday, we'll do the mole equation. Okay? Everybody with me there? All right, guys, if you're struggling with any of this, please come in and see me for help. Okay, there's lots of opportunity to do that. Okay, just pop in. Good job today, guys.